my name is Staff Verhagen. I've put my email address there, so if you want to reach me afterwards, you can reach me. So I'm talking about a project I'm doing, Rtl microcontroller. And the title is an open source microcontroller with Rtl instruction sets. Plural. So, explanation. So first I'm going to tell you what it is, why I'm doing this, what the status is, and then I propose first thing that you can get reaction. So what is it? It's a microcontroller with a Z80, a MOS 6502 and a Motorola 68000 core on it. So this is just a logo for that, but it will be combined on one chip, so on the board, so that you can use it. More details later in the presentation. So why did I do it? We're in retro computing, so it's a hype, I think, now, retro computing. All these guys who are young and grow up with the Commodore 64 or a Spectrum, they want to go back. They have money now and to feel young again. Like if you get gray hair and these kind of things. Actually, I'm started with the Commodore 64 and afterwards I moved to an Amiga. And so I've been quite Amiga. And if you see the retro computing guys, you find in this world people who currently at this stage pay 240 euros for a 40 megahertz accelerator with 122 megahertz RAM on them. So that's what people pay now for in the retro computing guy. So, and also you have the MIST FPGA, which simulates quite some old computers. That's for 200 euros. And there are even people making a new Atari clone for more than 500 euros, and they seem to be able to sell these things. So what I just want to say is that money is not so if some people would like to do it, and they probably want to spend some money on it. Of course, there is always a border you cannot go above, but yeah. And then the other part, which is now also I think a hype, is the maker movement, hobbyists. You have the Arduinos, the Raspberry Pis, and ESP32 and these kind of things. So, and I thought, yeah, these two things, maybe I can combine them. Maybe somebody wants to do these maker type things, but with an old instruction set. So that's what I'm doing. But it's actually a broader view, is that you have the open source movement for software, which started around 20 years ago with Linux and all these things. And what you could do there is that you had people who could hack at night, had a PC, and overnight they could start working on these OS systems and Linux and all these things. And they could do things, and yeah, you had what it's called a news, what do you call it again? The news system that before you had Facebook and Twitter and all these things, you had these forum type things on the net. Yeah, news groups, yes. Sorry. So, but if you want to do custom ASICs, it's typically ASICs are considered that you need high startup cost and you need quite some volume. So I would like to make it possible for people to also work more in that regime, but of course you probably cannot do it alone. But what you do have now, you have crowdfunding, you have Kickstarter, crowd supply, all these things. So if some people can come to a minimum number of 50 or 100, then maybe we can also do it for ASICs and get the open source vibe also getting in the hardware ASICs world and not pure in the software world. And you also have the distributed development, GitHub, GitLab, so it's much easier to cooperate on things worldwide. So you only need to find 50 or 100 crazy people in the whole world that want to work on something and to make something to do that. So what is my dream? Is to make it possible to have low volume open ASIC service. So typically, like I said, it's considered that you need high startup cost, and it's all your so chips are made with projecting things on that, and what you use as projecting is called the masks, and these are quite expensive. You have the tools that you have to make, which are commercial, Cadence, Synopsys, these companies, and you also have to pay a lot for them. So even if you can make cheap chips, you have to use expensive tools. And if you make ASICs with a hacked tool, they probably will find you when it becomes popular. So and also typically this is done by experts which are paid to do the work. So you need to pay the people writing these things. You have the IP blocks. If you have a block that does something special, then it will also cost money, and everything has its own. And also all these things, they come with NDAs, EULAs, which are typically not open source friendly. And there is already a few years that we have the open hardware or the open ADA dev room here at FOSDEM, where they try to look at these things and solve these things, and I also said maybe I can solve them. Actually, I'm working as professional live in IMEC here in Belgium, which is a research institute for microelectronics, but they also have a group that provides services to make ASICs, and that's why I know how this works and what the costs are, and I'm trying to, with that knowledge, to get this working. It's a hobby project, so it's not because my work doesn't see enough volume in this yet. Hopefully it's a yet, to spend resources on that, because it's typically for high. So how do I want to solve this is, I would like to be able to make boards with open source ASICs on them, less than 100 euro per piece if you order 100 boards. So it's around 10K that you need to find, but with crowdfunding I don't think, if you see for remaking some old games of old times, that they can spend hundreds of thousands of money, so 10K should be possible, I think, if we spread the word and get people knowing that is there. So, and I also want to have a library of open source RTL. So RTL is the type of licenses in which you write hardware. It's called a register transfer language, which is actually event driven. It has special languages, VHDL, Verilog, that you have to learn. And I want to have that open source also. Typically it's proprietary. In order for this to work, you probably still have to pool 4 or 5 projects on one run, and then that you still can share some of the setup costs. But again, if you do that with the crowdfunding side, it should be possible. Say, we have 6 projects. If 4 of these projects are making it, then we can go for the run. Of course, it has implications on how far you the lead time. So you're talking about months there before you start your product and you get the final product. But this is retro computing, so what's 1 year more than about computers of 20 years old? So I also talked about this register transfer language. You have to be a really expert to do that. So I want to have a flow that is fully push button, that you actually don't have to take care of yourself, that actually it can be in the cloud somewhere, that you don't have to do it yourself, because I don't think it's possible to get everybody an expert. I would already be happy if people could start writing this RTL type of code. And also, I have now a company. I want that to be as an intermediary for the legal affairs, so that I can take care of the legal stuff, and that the people want to make something, that they don't have to take care about that and don't have to mind of it. Of course, it means that if I use something proprietary, I cannot give it to the people. So I'm pro open source, but I'm also a little bit pragmatic. I'm not yeah, I have to pick my words carefully, I think. I don't see that there is a that everything has to be open source. So being pragmatic and combining open source with closed proprietary software sometimes I think is not a problem. But I do like open source because I think in this EDA flow, I think there is still a lot of innovation that can be done if people can work on them in their free time. Because this is now following the new technology nodes, 28 and 14 nanometer and 10 nanometer and 7 nanometer. And actually the companies who make this software are actually focusing on getting their tool working for that node. And actually these older nodes, they don't look at them anymore. And if we could have a flow that's open source, I think also a lot of innovation could happen still there, even for the mature nodes. Okay, so then I have this project, which is actually a pilot project to test some things about costs, about the flow, to then later on maybe go for, I do this project myself, but then later on I can let other people do projects. So what's the current status? I have a project page on hackaday.io. You can find the site here. So I don't know if you know hackaday.io. That's a site where a lot of people who do this kind of open source things, hacking, put their projects. One of the projects I like a lot, or they are doing really amazing thing. That was, you have a relay with real coils, and if you take 2 of them, you can make an half adder with them. And then he made 4 PCB boards, and there was a 16-bit adder with real relays with coils. And I really feel it amazing what people are doing and spend their time on. So I also have a blog site where I once in a while post something, but of course the time I spend on making blogs I cannot spend on the other things, so it's not that I blog every week or so. But you can follow me, what's happening. If there is major technical projects, I will put it on my blog, so that you don't have to follow the GitHub closely, so that you still know what's going on. And then I have the source code, so everything I do, I want to make that open source, and I have that on GitLab. That's also personal preference. I prefer GitLab over GitHub because GitHub is closed source. A few years ago I used sourceforce.net, and then that company was bought, and then at a certain point they went proprietary, and they made problems, and they lost a lot of people. And the same thing can happen with GitHub. And GitLab is fully open source, so even if github.com stops, then I can host my own GitLab server. GitHub also has, I think, corporate or version that you can install it yourself, but I think you have to pay for that. So let's go over the source code I have. Is that these are the submodules. So my chip will also have a JTAG interface. It's used for testing PCB boards, so they call it boundary scan. So you can put the IOs in a certain state, so you can test your PCB afterwards. That's for testing the chip. But it will also be, I will also use that to program the device, so you can load your programs in RAM on the CPU, on the microcontroller in that way. I probably won't have non-volatile on the microcontroller because that's own IP, so it has to be booted from something external. But what I do plan to is that you can boot it from an I2C flash chip, so that it has I2C, that if you enable that it just loads what's in the flash into this RAM of your CPU, and that it boots in that way. but you can also turn it off so that you can boot it through the ETAG interface. Then I have the T65 and T80 cores, which are actually coming from these FPGA boards that make these old computers. So I took the cores that they used for emulating the Commodore 64 and the ZX Spectrum. I used that one because they are battle tested. They have been run to the demos that the people made at that time on the CPU, on the machine, so I can rely on it that it will work and it will function. And then you have the AO 68000, which is a separate project. I first had another core selected, but that is GPL licensed, and that has some complications because if you have something GPL licensed, everything you use you have to make public, and I at the moment cannot make everything public. You implement an ASIC with what I call standard cells, which are a standard cell is a block that implements logic functions, and then a NOR or a register, a logic, a memory element, and these I will use proprietary for that, and that's for I needed a permissionless licensed open source course for now. In the longer term, I also want to make this standard cell library. I want to make an open source standard cell library. There is one available, but that's GPL code, and that's also not what I want. I don't want that the standard cell library decides a license that you can use for everything you put on top of it. I don't want to force everybody to make only GPL licensed products based on the library. So this is what the RTL code. Yeah, I didn't make a schematic of this, but this actually will represent the block diagram of the chip. You have the different cores. You see, I don't have the 68000 yet integrated here. There will be on-chip RAM. It will be only a few kilobytes of memory, probably, but for Arduino type of things, I think that should be enough. There will be an arbiter that determines which of the cores get access to the memory. So, but it's determined at boot time. For the moment that you enable one of the two when you boot your thing. People are also asked if you can let them run at the same time. Maybe, but then I have to be careful that I don't make any mistake, that I don't have the risk that when the chip is there, that it doesn't work. So it's always a risk of providing features, but making a bug in the feature is, you cannot fix a feature in a hardware chip. Then you have to order a new set. It's not an FPGA or some other thing. So I have to be careful there. And then the Wishbone bus, which is actually the memory block. So it interfaces to the on-chip RAM, but also the IOs. The IOs will be memory mapped in the memory map, so that you can write to the IO to put it on or off. And it's not there yet, but I also plan to include some blocks like an I2C controller, UART controller, a PWM controller. I think all these things you want to have in a microcontroller. I will include some of them. I also have to see how much area they take, but that's still under development. But so follow my project and you will see what I will implement. So I also do simulate what I write. So typically you want to be sure that everything works, so you do simulation of your code. And this is then, I use CocoTB, which is a Python thing that does coroutine simulation of hardware descriptions. And I'm using that, and you see that I'm testing everything to see if it works. And actually I wanted to show a demo today, but actually the simulation showed that I was not ready and that I still had problems, so that it should not work. So there's no excuse, but of course I could have brought in and say, oh, it doesn't work, but I'm not that kind of guy. So then I'm actually testing this on a Accelerate board. So it's a board with an FPGA on it that really tries to mimic an Arduino. So they even they included the voltage transfer, because Arduino, the original Arduino, is 5 volt, and most FPGAs are 3.3 volt yet. So they included the voltage shifting, even for the analog one. So they use the 5 volt analog signals to 3.3 volt signals on their board. And I'm using that to test everything. So then the question is, do we need hardware? I think some people want to have hardware and not just FPGAs. So I hope. But I'm doing crowdfunding, so I will see if I'm the only one who wants that or if there are other people who want it. But then I also make boards different, so I will have different options. I will show you later on. So you can also find the KeyCut, which is a PCB design tool, source file in that GitHub. So these are the the 3 boards, and then the bare chip. So like I said, I'm doing crowdfunding. So this is I'm on Crowd Supply. So this is my site where you can go for So I haven't launched it yet. So you see that I'm from the software side. I think it's doable, but there are still a few loose ends on the budgeting side I have to fix. And I hope it will be in the next weeks, but I've thought that already a few times, and then always some things pop up. So I only want to really launch the campaign when I'm sure that I'm 90% sure that I can do it actually. I don't want to launch it and then say, oh, later, yeah, I cannot do it. So if you're interested, you can register your email there and you will get a mail when it's launched, and then you can buy it. So what are then the planned product options? It's the chip itself. Maybe let's first say the first idea I had was to make three different chips, one for each core. But then I saw that actually the area of the on-chip RAM is much higher than actually the cores themselves. And then it would be not cost saving, it would not cost much more to put all 3 on the same die. And then combine them, and that you then just choose which one you want to run. Then making 3 different chips. And also having 3 different chips makes the logistics much more difficult, because you have to separate in the whole flow your 3 chips all the time. If you put them on a PCB, then you have to know this is a PCB with a 6502, this is a PCB with a Z80, these things. So putting on one chip is easy. Also, I've seen that the packaging also takes quite part of the cost. So originally I also planned to have a one with lower I/O, so the normal Arduino, and one with higher number of I/Os, the Arduino Mega, I took as an example. But I saw that the price of the two was so low that I just went for the high I/O, and then only had one chip left, which is the logistics easier again. So you have the chip only. I also want to make a board where the chip is on that and that you can use for breadboarding. So you can a breadboardable one. You can just use the 2 outer, so you can make it fully functional by the 2 outer rows. But if you really want to have more I/Os, you can also use the inner arrays. You will need to provide the clock and these things, so it won't function on its own. But people who use the 6502 now on a PC board are used to providing these things, crystal oscillator and these kind of things. And you see that is also dip switcher, so that is to be able to select which core you want to run and if you want to boot from I2C or not. So that's the feature I planned there. If you don't boot from I2C, some of the pins are the JTAG interface, you have to program through the JTAG interface. Then also I have there was a crowd supply where they have some kind of prototyping boards, but they were special. It was called Perf Plus 2. And actually it's a prototyping board where on the front side of your PCB you have horizontal lines, and on the back side you have vertical lines, and you can make connections by soldering actually the vias here. So I think, and it allows you to make prototyping boards without needing jumper wires. So you could do the routing with soldering. I find that very interesting, and I also want to provide an option that you can select a board with that. So then you get the chip, and then you put your own components on there. And then finally, I want to have a Rtrino, an Arduino compatible. I call that Rtrino. So there I couple my chip with an STM32 microcontroller that actually has a USB interface, so that you can just program it to a USB on a PC. And this microcontroller next to it has on-chip flash, so it should be able. So once it's programmed, you just have to provide it 5 volts on the USB port, and then it will just boot the retro microcontroller from the STM32. So it can be run standalone if you provide it 5 volt, and also the 3.3 volt is generated from the 5 volt. So the chip for I/O use 5 volt, but the technology, the logic of the technology runs at 3.3 volt, or if enough people are interested and we can go to a lower technology node, it will be 2.5 volt. And that's generated all from this board. So once it's programmed, you can just run this board by providing it 5 volt with any USB charger. So that's the thing. So these are the options I foresee now for the crowdfunding campaign. So then I have, what I'm interested to know is that, do you think that people would be interested, or some people would be interested in this crowdfunding project? So for one project, the goal would be 10,000 price per piece, less than $100. And I mean they're fully assembled PCB boards. The chip itself will be cheaper. And what is interesting, I think, by using mature nodes, I think we should be able to combine 5 volt or 12 volt or even higher volts on that chip. Because typically if you go to FPGAs, they stop at 3.3 volt. And we should be able to even do serial communication, RS-233 on chip. So everything combined. But of course, as mentioned before, the production will be slower, so we're talking about months and not weeks for PCB, custom of the shell parts designs. And what are your requirements? What do you think are requirements to make it at least? So that's just a guidance of remarks you may give, or if you have other questions, feel free to ask them. Okay.
Why do you think having an ASIC is better than an FPGA on this context?
So you asked, why do you think that the ASIC is better than an FPGA? I would not talk about better or worse. I think some people just would like to have an ASIC. So there are now also accelerators made for Amiga, for example, with FPGAs, and just people don't like that it's an FPGA, that is programmable. They want to have ASICs. But also, like I said here, the 5 volt capability, the 12 volt capability, you typically don't find in FPGA. And then you have to use interface chips. It depends on your personal preference. Yeah.
Question.
Yeah.
Have you considered making specific ASICs to get retro computers from the dead? Basically, for example, the ULA from the ZX Spectrum, or specific chips for the Amiga that we can't find anymore. That would be a nice goal, I think.
So the question was if I consider to actually make new batch of existing old chips. I think the price per unit will be too high for that. I'm talking about 20, 25, 30. So that's the question if it's too high. I think I prefer that doing that, but then maybe combine more than one chip on one chip, because the price won't matter that much. From the other side, when I can make this a service, and if people think it's a project that they want to do, they can do it. Or if you want to do that, you can always contact me and we can find a way of doing it. It's no problem. If you see there is a need for that, we can launch it. Of course, I first have to get this first project done before I can start to think about other things. But I don't see a problem with that. Yes. Yeah.
Will you? So all of these chips have different buses in the original form. Will you provide those buses as well, or will there only be the reading or type I/O on them?
So the question was if I will provide the different buses of the chips. Currently, I choose the microcontroller so that you just have I/O and not a memory bus or so on the output. It should be no problem to actually make a chip that, if the chip is in 6502 mode, that these pins are this bus, and if you're in Z80 mode, that these pins are another bus. That should all be possible. But I wanted to reduce the risk. I want to limit the code I have to write on RTL as low as possible to reduce the risk that the chip will have a bug when you get it. That's why I want to use for this project battle test it. But these things can all be done. But that's for later on.
Yes, I was wondering why you choose QFN package, because typically for the maker/hobbyist type of people, it can be really difficult to use it compared to a QFP, which can be soldered with a regular soldering package.
So the question is, why did I use a QFN package and not a QFP package, for example? It's not fixed yet, but that's also, so the startup cost of packaging is, so I wanted to have this Arduino Mega, so a lot of IOs, so you have to have 100 pins. And if you want to package something, you have to use what they call open tool, so packages which are available to package, that shop that IMEC works with has available, because if you don't do it, then you have to pay startup costs to create your package, and that's also 10K. But it's not fixed yet, so it can be that I switch to QFP again. So that's not fixed yet, but it will be determined by cost for this first project. But do you think it's really easier to QFP soldering than?
It's a big step in soldering QFN compared to QFP.
Okay.
In QFP you can do it with a regular soldering iron.
Yeah, so at IMEC they told me this is a QFN package with 0.4 millimeter pitch, that you should still be able to solder just by putting solder paste on it and just put it on it and put it in an oven.
Yeah,
And it should not have
The cost difference in actually packaging a QFN versus QFP is about 25%, and that's the whole reason that companies have gone to QFN, is there's a huge cost savings in that.
Yeah.
it's
Big.
cheaper to make QFN.
Yeah.
Absolutely.
Yeah, because you have in the QFP you have the pins that are sticking out, so it's more difficult to make them, and because the cost is lower, they have now all having these open tools for QFN and less for QFP.
Exactly.
Yeah,
You kind
so-
of have to follow the market trend on this.
Yeah.
Because you have to select what's available from the company that will actually pay for you.
Okay, all right, thank you.